right, what did you get for the formula for magnesium nitrate? MgNO3 plus NH3 plus H2O. Okay. Does that look right? Yeah, NO3, we need 2 nitrates. Nitrate is a -1, magnesium plus 2, so 2 nitrates to balance out the charge. Okay, what does this form? MgOH2. Two ammonium nitrates. NH4, NO3. Okay, good. All right, so is this balanced? Well, first we need a driving force. Is there a driving force for this?
Yeah.
Yeah, what is it? Precipitate. This, magnesium hydroxide. And then the other states, H2O is a liquid, so we'll have to put that. The rest are aqueous. So we're okay there. Okay, now let's balance it. If there's a driving force, we're going to make sure it's balanced. We're going to have to, yeah, 2 ammonias and 2 waters. Okay, now it's balanced. Okay, so we'll just say over here, DF, precipitate. All right, this is what we call the complete equation, conventional. Then we're going to go to the IE. What did you have for your IE? Mg2 plus 2 nitrates, okay. Plus 2 nitrogen 3 plus. Plus 6 hydrogen ions, like this. Plus 2 water. Is that what you got, Shima, or you got something different? What did you get? Did anybody else get something different?
I said ammonium plus hydroxide.
You write, okay, so or you got, what did you get? Ammonium plus hydroxide?
Yeah,
2 ammoniums plus 2 hydroxides?
Okay.
Is that what you got? Okay, did anybody else get something else? All right, well, the first thing is this. Do bases ionize, or do bases ionize? Bases don't ionize. Bases hydrolyze. So we're going to eliminate that. We don't want to ionize it unless it's a salt like sodium hydroxide, but that's a salt. Salt's ionized. All right, now we could hydrolyze it like this. However, each reaction says this. I'm taking the reactants. What are the reactants? Magnesium and nitrate and ammonium and hydroxide. Well, are you going to go to the store to buy ammonium hydroxide, or are you going to go to the store to buy ammonia? When you go buy a bottle of ammonia, you're getting 1.3% ammonium hydroxide, 98% ammonia. But you say, I don't want 1.3% ammonium hydroxide. I want 98% ammonium hydroxide and 1% ammonia. And so, you know what? You say, I'm not happy with the K being 1.8 times 10 to the minus 5, because the K of 1.8 times 10 to the minus 5 means I have mostly ammonia and just a tiny bit of ammonium hydroxide. I want to flip it. So when I go to the store, I'm going to demand it. Rather than being 10 to the minus 5, I want it to 10 to the positive 5. So I said, okay, give me the stuff that's 1.8 times 10 to the positive 5, which is all ammonium and hydroxide. What are they going to say? They don't have it. Because all they have is this. You can't change the balance. The balance is always going to be fixed. And so this stuff is there, yes, but this is not what we buy. What are we buying? we're buying 2 ammonias and 2 waters. And so this is key here, because what the equations, each of them should show is this. Okay, yes, there's pyruvate. There's pyruvate when you eat foods. You're going to get some pyruvate out of your foods. But are you eating just pyruvate? No, and so this is the same thing. Rather than saying, yes, this is the pyruvate's critical in this, but that's not what you get. You get ammonia and water, and a little bit of that will automatically form a little bit of this. And so the reactants are what we're going to actually mix. And it's like, the foods that we actually eat. Yes, pyruvate's there, but it doesn't mean you have to start with pyruvate, and we don't start with pyruvate. We start with ammonia and water. How about magnesium hydroxide? Do we ionize that or leave it alone?
No.
Leave it alone? How about ammonium nitrate? Do we ionize that or leave it alone? We ionize. Soluble salts, we ionize. Into what? Now, do we break apart the ammoniums into nitrogens and hydrogen ions? No, that's going to stay together as 2 ammoniums. And then the nitrates, do we break that up into nitrogens and oxygens? No, so this is going to stay as 2 nitrates here. All right, so let's go on to the NIE. The NIE is going to show what? So what's the spectators here? Is magnesium a spectator? No, it reacts. Is nitrate a spectator? Yes. Nitrate. Is ammonia a spectator? No, it's not, because you have ammonia NH3 here, but over here we have ammonium NH4, so something changed. And so ammonia and ammonium are different. Ammonia is considered a weak base, ammonium is considered a weak acid, so they're different. And water did change too, because there's no water there. So the only spectator is nitrate. So we're going to eliminate that. And then we get Mg2 plus 2 ammonia plus 2 water yields magnesium hydroxide solid plus 2 ammonium. And so this would be the NIE, the net ion equation. All right, so are there any questions on using aqueous ammonia? I mean, basically we need if it's a +1, like silver, we just need 1 ammonium, 1 water. If it's a +2, like magnesium or copper 2 or iron 2, we'd need 2 ammonias and 2 waters. If it's a +3, like aluminum 3+, we'd need 3 ammonias and 3 waters. And then we're going to precipitate out the hydroxide. All right, so this came from back when we were talking about metathesis reactions at the beginning of the semester. All right, I forgot exactly what we were talking about. All right, so we did a little bit of acid-base review and some equilibrium, Le Chatelier's principle. All those things come into play in this particular problem. Now what we're going to do is we're going to talk about redox reactions. One application of redox reactions is in building batteries. So can you sketch out how you build a battery? Like this, We're going to have our oxidizing agent. It's copper. Let's go with copper nitrate, copper 2 nitrate. And our reducing agent is going to be zinc solid zinc metal. Can you sketch out a, what do we call it, voltaic scale? I.e. battery? Or this? What would the battery look like? You label it. Yeah, you got to make a drawing of that. Can you do it? Okay, do it.